Okay, so ready for a deep dive into AI.
Always ready.
But forget self-driving cars for a sec. We're going deeper into the brains behind the bots.
Transformers. Yeah, you might be surprised to hear these revolutionary models are more connected to their older, less glamorous cousins,
Oh, really?
the RNNs,
Okay.
than we originally thought.
It's like finding out your favorite band was heavily influenced by...
Polka music.
Exactly.
Right.
Not that there's anything wrong with polka music, of course.
Of course not.
But let's unpack this family reunion.
Okay.
Our source material is a paper called Transformers Are Multi-State RNNs.
Yep.
By Matanel Oren, Michael Hassett, and their team.
Their team, yeah.
They've made some seriously cool discoveries
They have.
about how these AI models actually work.
Yeah.
Okay, so before we get into Transformers doing the electric slide with RNNs, let's break it down.
Okay.
What exactly is an RNN?
Right.
I know it stands for recurrent neural network.
It does.
But my brain is still stuck on the polka thing.
No worries. I think the polka image is hard to shake.
Yeah.
But imagine you're reading a mystery novel.
Okay.
As you get to each chapter,
Yeah.
you're not just taking in the new information. You're also remembering clues, characters from earlier chapters
Okay.
to build the whole story.
Yeah.
That's essentially what an RNN does.
Okay.
It processes data sequentially,
Mm-hmm.
like words in a sentence,
Right.
keeping a memory of what came before.
Got it. So they're like little digital detectives.
Yeah.
Always piecing things together.
Always.
But now we got these MSRNNs.
Right.
Or multi-state RNNs. Are those like super detectives with photographic memories?
Precisely.
Okay.
Think of an RNN
Mm-hmm.
with a much bigger memory bank.
Okay.
Instead of just remembering the last chapter,
Right.
they can hold on to details
That-
from multiple chapters at once,
Okay.
building a more intricate understanding
Mm.
of the whole book.
Okay. I'm starting to see the family resemblance here.
Yeah.
The Transformers.
Mm-hmm.
Those are the AI rock stars of the moment.
That's right.
Everyone says they're different.
Mm-hmm.
Groundbreaking.
Right.
How do they fit into this RNN family picture?
Well, that's where things get really interesting.
Okay.
This research suggests that Transformers,
Yeah.
despite their fancy new architecture,
Huh.
can actually be seen as a type of MSRNN.
Okay.
Just one with a truly massive, almost unlimited memory.
Wait, so they're remembering everything?
Pretty much.
No wonder they can write poems and code like crazy.
It's really something.
But wouldn't that be super inefficient?
It can be.
Like having to carry around a library everywhere you go?
Exactly.
Okay.
And that's one of the big challenges with Transformers. That unlimited memory,
Right.
while powerful, can also be a computational bottleneck. It takes a ton of processing power
Yeah.
to keep all that information active.
So it's like they have this incredible potential, but they're also a bit,
High maintenance. You
Yeah.
could say that.
okay.
And that's why this research is so exciting.
Okay.
It introduces a technique called TVA,
Okay.
which essentially helps to
What is that?
bound the beast,
The bound the
as
beast.
the researchers put it.
That sounds intense.
It is pretty powerful stuff.
So is TVA like a personal trainer for Transformers?
In a way, yes.
Okay.
Helping them slim down and get more efficient.
Right.
TVA stands for Token Omission Via Attention.
Okay.
And what it does is limit the memory of a transformer,
Oh,
turning it into a more manageable, bounded MSRNN.
okay, let's unpack that.
Okay.
First,
Uh-huh.
what's a token?
Right.
Is that like a secret AI password?
Not quite that exciting,
Yeah, okay.
but still important.
Right.
In this context, a token is just a basic unit of text,
Okay.
like a word or a punctuation mark.
Got it.
Think of it like the building blocks of language
Yeah.
that the AI models are processing.
Okay, so TVA is basically deciding which of these building blocks are important enough to keep in memory
Exactly.
and which ones can be, shall we say, decluttered.
Exactly.
Okay.
And the key to this decluttering process is attention.
Wait, hold up. Are we talking about like mindfulness meditation for AI now?
Haha, not quite.
Okay.
Though maybe that's the next big breakthrough.
Right.
But in the world of Transformers, attention is a mechanism that allows the model to focus
Okay.
on the most relevant parts
Right.
of the input text.
So TVA is like a super focused student
Yeah.
who can highlight the key points in a textbook
Uh-huh.
and ignore the fluff,
Right.
allowing them to ace the test
Yeah.
without memorizing every single word.
That's a great analogy.
Okay.
And what's remarkable is that TVA is surprisingly good
Right.
at this selective remembering.
Uh-huh.
The researchers found that in many cases, TVA, with its limited memory,
Yeah.
performed just as well. as a transformer with its unlimited memory.
Whoa, that's impressive.
It is.
It's like saying you can bake an award-winning cake without using half the ingredients.
Right.
But how does TVA decide what to remember?
That's the real question.
Is it just randomly tossing out words?
Well,
Or is there some method to the madness?
definitely not random. Definitely not random. TVA analyzes the attention patterns within the transformer, figuring out which parts of the text the model itself is finding most important.
So it's like
2VA is reading the transformer's mind
Right.
and saying, okay, you really seem to be focusing on these particular words and phrases, so let's make sure we keep those in memory.
So it's kind of a collaborative effort.
Exactly.
Like the transformer is pointing out the important stuff,
Yeah,
and TVA is taking notes.
that's right.
I like it.
And what's fascinating is that TVA doesn't just prioritize the most recent information.
Oh, really?
It actually learns to hold on to specific types of tokens that are crucial for understanding the overall context, even if those tokens appeared much earlier in the text.
Interesting.
Yeah.
So it's not just about recency bias.
No.
Like remembering the last thing you heard.
Right.
What kind of tokens does it tend to cling to?
Well, one of the biggest surprises was that the very first token
Okay.
in a piece of text is often the most important one for TVA to remember.
Huh.
It's like setting the stage for everything that follows.
Wow. So first impressions really matter,
They do.
even for AI.
Apparently so.
Does that mean we should all be spending more time crafting the perfect opening lines
Maybe.
for our emails and presentations?
It's certainly a thought-provoking finding.
Yeah.
But beyond that initial token, TVA also seems to prioritize things like possessive endings and proper nouns.
Like names.
Those names.
Hold on. Grammar is important to AI.
It seems so.
I thought they were all about crunching numbers and probabilities,
Right.
not diagramming sentences.
Yeah. Turns out, even in the digital world, good grammar makes a difference.
Okay.
It seems like TVA is picking up on the subtle ways that grammar shapes meaning. Possessive endings indicate relationships and ownership,
Right.
while proper nouns highlight specific entities.
So TVA is not just memorizing words.
Nope.
It's understanding how those words connect to each other
Exactly.
to create meaning.
Yeah, it's like it's building a mental map of the relationships within the text.
Interesting.
And this is a key area where 2VA differs from other memory limiting techniques,
Okay.
which often just focus on keeping the most recent information. TVA is more nuanced,
Right.
recognizing that sometimes older information,
Yeah.
like that first token or a crucial proper noun, can be essential for understanding the whole picture.
Okay, I'm starting to see why this TVA thing is such a big deal.
It's pretty amazing.
It's not just about making AI more efficient.
Right.
It's about making it more intelligent,
Yeah.
more like how humans actually think. But if we're basically turning transformers into super efficient RNNs,
Right.
does that mean RNNs are making a comeback?
That's an interesting question.
Yeah.
There's definitely been a renewed interest in RNNs lately,
Okay.
with researchers exploring new ways to overcome their limitations.
So what's old is new again.
Okay, so
I guess the AI world is just like the fashion world. Everything cycles back eventually.
there might be some truth to that.
Yeah.
But I think it's more than just nostalgia.
Great.
It's about recognizing that different approaches
Right.
have different strengths and weaknesses.
And sometimes the best solution is to combine the best of both worlds,
Exactly.
like a vintage dress with modern accessories.
I like that analogy.
Yeah.
This research is a great example of that.
Okay.
By understanding how transformers relate to RNNs, we can potentially leverage the strengths of both architectures
Right.
to create even more powerful and efficient AI systems.
Okay, so we've established that 2VA is this amazing tool for making transformers more efficient.
It is.
But are there any downsides to limiting their memory?
That's a good question.
Are we sacrificing some of their unique capabilities?
It's definitely a trade-off.
Okay.
There might be some tasks
Right.
where having access to a vast, unbounded memory is truly beneficial. But what's surprising is that in many cases, limiting the memory with PVA
Yeah.
doesn't seem to have a significant impact on performance.
Oh, wow.
It's like they're so good at picking out the right information
Right.
that they don't need to remember everything.
So they're not just remembering a lot, they're remembering smart.
Exactly.
That's pretty remarkable.
It is.
But I'm also wondering about the bounding the beast concept.
Okay.
Is there any debate about whether transformers are truly unbounded in the first place?
Yes. That's a key point of contention in the field.
Okay.
Some researchers argue that even though transformers can theoretically process any length of text,
Right.
they're ultimately limited by the amount of data they were trained on.
So it's like they have this incredible capacity for knowledge,
Yeah.
but their library is still finite, right?
Mm,
They can only draw from what they've already read.
that's one way to look at it.
Okay.
But the counter argument, and the one that this paper leans towards,
Hmm.
is that at inference time,
Okay.
when they're actually being used,
Uh-huh.
transformers are only limited by the available computing power and memory.
Meaning, if we had truly unlimited computing power,
Yeah,
they could keep learning and expanding their knowledge indefinitely.
potentially.
That's both exciting and a little terrifying.
It definitely raises some interesting questions.
Yeah.
But I think the key takeaway here
Yeah.
is that even if transformers aren't technically unbounded,
Right.
their ability to continuously add to their memory
Huh.
makes them fundamentally different
Okay.
from traditionally bounded models.
So they're constantly growing and evolving,
Yeah,
like a living language system.
exactly.
But this whole conversation is making me think about how WE communicate.
Oh, yeah.
If the first token is so important for AI understanding,
Right.
should we be paying more attention to how we start our sentences and paragraphs?
That's a good question.
Could a strong opening line have more of an impact on AI than we realize?
That's a fantastic question.
Yeah.
It highlights the fact that as we develop more sophisticated AI, we might need to adapt our communication styles
Okay.
to ensure we're being understood effectively.
Right.
It's not just about teaching AI to understand us, it's about us understanding AI and
Right.
adjusting our approach accordingly.
Right. It's like learning the customs and etiquette of a new culture.
Exactly.
We need to speak the language of AI, so to speak.
Yeah.
But this also makes me wonder,
What's that?
if 2VA is so good at picking out these key bits of information,
Right.
could it also help us better understand human language processing?
That's a brilliant insight.
Yeah.
By analyzing what TVA prioritizes,
Yeah.
we might gain a deeper understanding of how our own brains process language. For example, if Tovia consistently remembers certain grammatical structures or types of words,
Right.
it might suggest that those elements are particularly important for conveying meaning,
Ooh.
even to us humans.
Wow. So we're using AI to reverse engineer the human mind.
That's one way to put it.
That's mind-blowing.
It is fascinating, isn't it?
It is.
And it speaks to the interconnected nature of AI research. We're not just building machines.
Right.
We're gaining insights into ourselves.
I love how this deep dive has taken us from the cutting edge of AI research
Yeah.
all the way back to the foundations of neural networks
Uh-huh.
and even into the workings of the human brain.
It's quite a journey.
It's a great reminder that progress isn't always linear.
Right.
And sometimes the most groundbreaking discoveries come from revisiting old ideas with fresh eyes.
Absolutely.
Uh-huh.
And that's what makes the field of AI so endlessly exciting.
Yeah.
There's always more to learn, more connections to be made. And who knows what amazing discoveries await us just around the corner.
So we've gone from polka music to digital detectives to reverse engineering the human mind.
It has been quite the journey.
This AI stuff is wild.
It is.
But where does it all lead?
Right.
What does this TVA research really mean for the future of AI?
I think it points to a really important shift in thinking.
Okay.
For a while, the focus has been on building bigger and bigger AI models, almost like an arms race.
Yeah.
But TVA suggests that we might be able to achieve comparable performance with much smaller, more efficient models.
So we're trading in the gas-guzzling monster truck
Yeah.
for a sleek electric car.
Exactly.
Okay.
Less flash, but way more practical in the long run.
I like it.
This could be a game changer in terms of making AI more accessible and sustainable.
Okay.
Imagine being able to run powerful AI models on your phone,
Right.
or even embedded in everyday devices.
Okay. I can see how that would be super useful.
Yeah.
But part of me still wonders, are we losing something by limiting the memory?
It's a good question.
Are there certain AI tasks where that massive, unbounded memory is truly essential?
That's a great question.
Yeah.
And the paper does acknowledge that some tasks, like generating creative text or answering complex questions, might benefit from larger memory capacity.
I guess it makes sense.
Yeah.
If you're trying to write a novel or solve a complex scientific problem,
Right.
you need to be able to draw on a vast pool of knowledge
Hmm.
and make connections across different domains.
Precisely.
Okay.
But even in those cases, TSOVA could still be valuable.
How so?
Instead of trying to remember everything,
Mhm.
it could focus on identifying and retaining the most relevant information for a specific task,
Okay.
making the process more efficient.
So it's like having a research assistant
Yeah.
who can sift through mountains of data and highlight the key points for you,
Uh-huh.
rather than you having to read everything yourself.
Exactly.
Okay.
And this highlights a crucial point about the future of AI development.
What's that?
It's not just about building models with bigger memories. It's about understanding how to make those models more selective,
Mm-hmm.
more intelligent in how they process and prioritize information.
So it's not just about quantity, it's about quality.
Precisely.
We need AI that's not just a data hoarder, but a true knowledge curator.
I couldn't have said it better myself.
Okay.
And I think this research opens up some exciting possibilities for the future.
Like what?
Imagine AI assistants that can learn from our individual conversations
Right.
and tailor their responses accordingly,
Okay.
all while running efficiently on our personal devices.
That's the dream, right?
It is.
Having an AI that truly understands you
Yeah.
and can anticipate your needs.
Hmm.
Almost like having a mind-reading sidekick.
It's certainly getting closer.
Yeah.
And beyond personal assistance, imagine AI systems that can analyze vast data sets,
Okay.
like scientific papers or historical records,
Uh-huh.
to uncover hidden patterns and insights.
Right.
All while using a fraction of the computing power they currently require.
That's incredible. It's like giving researchers and historians a superpower.
Yeah, you could say that.
But before we get too carried away with the future,
Okay.
let's bring it back to our listeners.
Right.
What's the one key takeaway
Yeah.
you want everyone to remember from this deep dive?
I'd say the most important thing to remember is that our understanding of AI is constantly evolving.
Right.
What we thought we knew about these models even a few years ago
Mm-hmm.
is being challenged and refined by new research,
Right.
like the work on TOVA.
It's not just about these models getting smarter.
Right.
It's about us getting smarter about how they work and how we can best utilize their capabilities.
Exactly.
And as we continue to learn more about AI,
Yeah.
we might even be able to apply those insights
Right.
to improve our own thinking and communication.
That's a good point.
So it's a two-way street.
It is.
AI can learn from us,
Yeah.
and we can learn from AI.
That's right.
That's pretty profound a thought to end on.
It is.
But I do have one final,
Okay.
slightly mischievous
Oh, wow.
question for our listeners to ponder.
All right, I'm listening.
We talked about how the first token in a text is often crucial for TVA's understanding.
Right.
Does that mean we should all be obsessing over our opening lines,
Maybe.
crafting the perfect first words
Okay.
to grab the attention of our AI overlords?
Haha. That's a great question.
Yeah,
It's certainly something to think about.
right.
Perhaps the future of communication,
Hmm.
both with humans and with AI,
Right.
lies not just in the words we use,
Uh-huh.
but in how we frame those words.
Right.
The context we establish from the very beginning.
Intriguing, isn't it?
It is.
Well, listeners, that's our deep dive for today.
It's been great.
We've gone from the inner workings of neural networks to the future of communication.
We have.
And hopefully along the way, you've gained some valuable insights.
I hope.
And maybe even a few new questions to ponder.
That's right.
Remember, the more we learn about AI,
Yes.
the more we learn about ourselves. So
Absolutely.
keep exploring.
Keep questioning.
And who knows what amazing discoveries you might make.
That's the beauty of it.